Dear students, in this video we will discuss about a very important instrument in the amphibian physiology experiment, that is Du Bois-Raymond induction coil. So we already know about this circuit. This is the experimental setup, and in this setup we have two circuit. One is the primary circuit, another is the secondary circuit, and the instrument in this circuit can be divided into three headings. One is some of the electrical appliances, some are the recording appliances, and some are the miscellaneous. So Du Bois-Raymond induction coil, it actually comes under the stimulating appliances, and it has got three parts. One is the primary coil, secondary coil, and the Neff hammer. And where the primary coil is fixed, the secondary coil can be movable, and there is a calibrated scale in between them to indicate the distance between the primary and secondary coil. When the primary coil and the secondary coil, they are very close to each other, that means maximum electrical stimulation it can be given. So Du Bois-Raymond induction coil, why it is used? It is used to convert the available low voltage direct continuous current into a high voltage phasic, that is what is phasic, that is sharply rising and falling current. So at a continuous current is flowing, and we are converting it into a sharply rising and falling phasic current. So we can see here in the circuit we are starting with a 6 voltage current source. So this is a continuous current, and it has been converted into a phasic current in this Du Bois-Raymond induction coil. And as I told you, it consists of primary and the secondary coil, each made of well insulated copper wire wound round a soft iron core. So come to the primary coil. The primary coil is fixed and its terminals are connected to the DC source, while the secondary coil terminals are connected to the electrodes. We can see here in the primary circuit, we know that the primary circuit will start from the 6 volt DC. Then there will be the simple key followed by the kymograph. From the kymograph it will come to the primary coil, and the primary coil it will again come to the source. So it will form a circuit. So in this circuit actually the primary coil is located, and primary coil uh, is fixed and terminals are connected to the DC source. So we know that it is a DC source, and in the primary coil it contains around 300 tons of insulated copper wire. Now when the current will flow in this primary coil, we know that when the primary circuit is closed, then only the current will flow into the primary coil. When it is closed, in the kymograph at the end of the shaft, we know that there is one structure that is known as the striker, and when this striker will be in contact with the contact button, so these two are in a single point, so the circuit is closed, and at that particular time the current will flow in the primary circuit as well as in the primary coil. Now come to the secondary coil. The secondary coil has a much larger number of turns. The number of turns, it is around 5000 turns of fine insulated copper wire. Okay, so the wires are thinner than the primary circuit. Now the third portion of it, that is the Neff hammer. It is an optional built-in interrupters. Okay, connected in series with the primary coil. It works on the principle of electric buzzer. Suppose I want to increase the number of frequency. I want to see if I give multiple stimuli to the skeletal muscle, what will be the effect. Okay, so I want to increase the frequency. How can I increase it? If I take this Neff hammer into the circuit, how much it can increase the frequency? It interrupts the primary circuit about 40 times a second. Okay, so resulting in repeated induced current pulses in the same frequency. So it is used when the repeated high frequency stimulation have to be given to the tissue, and up to 50 per second this can be increased. Now one point is that in this Du Bois-Reymond induction coil, we actually trying to develop the induced current. Induced current is only developed when the electromotive force, its rate of current is changing. Okay, so there are two types of current here. One is when the primary circuit is closed, that is a make current. When the contact box and the striker is connecting, okay, so the current level is gradually increasing from 0 to say 10. So it is a make current. Current is building, it is making. So make current, and the magnetic flux within the secondary coil, it increases from 0 to maximum. Okay, and there will be an induced electromotive force develops in the secondary circuit. Okay, similarly, we know that the chymograph is not the striker is not, it is a standstill position, it is moving. Okay, so when it is moving out, so first it is touching and the current is rising from 0 to maximum, then it is again moving out. Okay, so when it is moving out, so current from highest level, it is coming down to 0, it is dropping, it is broken. So when the primary circuit is broken, that current is known as the break current. Okay, now the magnetic flux within the secondary drops to 0, and induced another induced electromotive force develops, because induced current is developed only when there is change of current. Okay, rate of change of current is there, then the electromagnetic force, that is field, that is developed. Okay, so in this way, so there will be two types of current. One is the make current, another is the break current. Okay, so which one is much more stronger? Obviously the break current is much more stronger, because here the primary circuit, the primary coil itself, it forms an electromagnetic field. So that is the reason why the break current is stronger than the make current. So here we can see that it is moving in this way. So when it is touching, so that is the make current, and when it is moving out, it is not, it is the break current. Now, one point is important. So, this Du Bois-Reymond induction coil, it is both included into the primary circuit and the secondary circuit. The primary coil is in the primary circuit, and the secondary coil is in the secondary circuit. So, primary circuit, we know it is a continuous current circuit. It is made by connecting all gadgets in series with the mains, and it includes the low voltage 6 volt DC, primary keep, chymograph, and primary coil. All additional gadgets such as variable interrupter, signal marker, they can be included in this circuit in series, and it is never in the secondary circuit. So if I want to change the frequency, if I want to increase the frequency, so in that cases some other gadgets like variable interrupters like this can be included into this circuit. Now the features of secondary circuit, it is a stimulating circuit. We can all see that from secondary coil to the short circuit key, then to the electrodes. So it includes gadgets connected in parallel, and it includes the secondary coil or short circuit key and the simulating electrodes. A constant strength of high voltage, low current flows through it, which rises and falls rapidly, so that the tissue damage will be minimal. So another instrument is there, that is the student stimulator. If we want to substitute all these Du Bois-Reymond induction coil, leaf summers and everything, we can substitute them by this student stimulator. It has a separate input, so we can very accurately regulate the frequency of electrical stimuli, the voltage, the pulses. So that is a separate video I have to make. So for this video, you will just learn that instead of Du Bois-Reymond induction coil, we can substitute them by this physiograph stimulator or the student stimulator. Thank you.